All right, my friends, I actually really hope you ran into trouble with this one because it turns out you actually cannot apply the comparison test to a problem like this one. And that is the point of part C. And so let's make sure that you know why. So first of all, what would you compare it to? So I personally would see if I can get rid of that little -5 there. So the sum as n goes from 1 to infinity of 2 over 3 to the n, which if you factor the 2 out, you'd have the sum as n goes from 1 to infinity of 1 over 3 to the n, which, my friends, is a geometric series with a common ratio of 1/3. And so I would say which is a convergent geometric. And then why am I saying that? Because the common ratio is 1/3. It's between -1 and 1, right? Okay, so if I'm comparing it to something that converges, so here's the geometric I'm comparing it to, right? For my logic to make sense, the comparison test, I would need these terms to be below, right? To say if the other one adds up to something finite, this one must as well. And so, but the problem is that you're actually dividing by a smaller number in this one. So you'll get a bigger result. And so we'll say, but, sadly, I don't know how to punctuate that, but sadly, do you encase it, commas? Sadly. Anyway, 2 over 3 to the n minus 5. Unfortunately, that would be higher, or it certainly wouldn't be less. Anyway, isn't that horrible notation? I'll say it is higher. Anyway, and so we'll say sad. So the point is that the comparison test cannot be applied. But hey, stay tuned, because while the comparison test cannot be applied, what's called the limit comparison test, which we'll talk about in part 2, will work like a charm. There we go. So I did want to give this example, though, so you could see that you really do have to check your positioning before you apply that comparison test. And they have ways on the AP exam of checking to see if you know your theory.